about the process that one piston, okay, so that can be operation when you are just expanding one piston. So suppose in that expansion your pressure remains constant inside the cylinder, so that is also one process, because from state 1 to state 2 you are getting one process, okay, means slowly it will be happening. It is a quasi-static process, very slowly, okay, it will be happening. Now cycle, what is a cycle? So cycle basically it is a number of processes through which the system will regain its initial condition, okay, means from 1.1 if it starts, then again after doing numbers of processes, process 1, process 2, process 3, okay, then you are reaching again the initial state. Suppose your room temperature is, let's say it is 30 degree, okay, and suppose it is a very shiny day. So what happened? So after 30 degree it may be 32 degree, so up to that much it is a process. From 32 degree to 35 degree after half an hour or 1 hour, that is one another process. And suppose after 35 degree again it reaches 32 degree, okay, that is also one process, third number process. Then after 32 degree to 30 degree means you are getting the initial condition, okay, so that process is a cyclic process, means number of processes will be 4, okay, and that will be one cycle, means from initially from where you have started finally you are reaching the same point. But the condition is that that process will be called it as a cyclic process only when the system property will be the same as that in the initial, and the surrounding property should be same as that in the initial, okay. So you should remember that thing, that your conditions, your parameters should be same as that of the initial condition. Suppose initially it was 25 degrees centigrade or 30 degrees centigrade, pressure was 1 atmospheric pressure, volume was that much, entropy was that much, enthalpy was that much, and after going back from 35 degree to 30 degree, again all the things should be remain same for the system. The pressure should be 1 atmospheric, temperature should be 30 degree, enthalpy should be that much, entropy should be that much, means initial condition and that final condition should not change, means the system will regain its original condition, the surrounding will also regain its original condition, then only that will be called it as a cyclic process, okay, means identity of the system it is not lost. Understood? Okay, now let me share the slide to understand what is first law of thermodynamics. Basically in mechanics, the first law of thermodynamics, how it is actually the first law of thermodynamics, how it is actually stated that energy can neither be created nor destroyed, isn't it? Means total energy inside a system it is remains constant, isn't it? So that is the definition of mechanics, okay, or physics. But here in thermodynamics, so we will denote or we will say the definition of first law of thermodynamics with the help of energy, okay, and the basic mode of transfer of energy is heat and work, isn't it? We have studied this thing. So basic mode of transfer of energy into a system or from a surrounding to the system or from system to the surrounding is only by mode of transfer of heat and work, isn't it? So heat is basically it is denoted by capital Q and work is capital W, okay. So here you can see one system, basically it is a closed system, that is why this square box I have taken. So it is a closed system. So the property of the closed system, okay, that system is defined by X and Y. Let us consider it may be P, it may be V, pressure and volume, okay, temperature and volume, anything. So I have taken it arbitrarily X and Y. So you can see from 1 to 2, one process through this path A, okay, and from 2 to 1 again this is another process, isn't it? Means two processes are here in this complete cycle. So from here it has started point 2, it has reached one process. So point 2, from point 2 to point 1 there is another process, and the part of this process 1 to 2 it is denoted by A, and part of this process 2 to 1 it is denoted by B, okay. So this is a thermodynamic cycle. Okay, so what it is actually said statement is that when a closed system executes a complete cycle, a closed system, it has executed complete cycle, the sum of heat interaction is equal to the sum of work interaction. So sum of heat interaction will be equal to sum of work interaction. So in process 1 to 2, there may be some addition of heat. Suppose you are heating one system, suppose your room from 30 degree to 35 degree means sun is heating. Okay, so the room is burning, sun is heating, means heat is going to the system. Okay, so if it is going to the system, it is negative, isn't it? So if it is coming out from the system, it is positive. Okay, so I am not considering the sign convention, just I am saying that from 30 degree to 35 degree the system is taking heat. Now what your air conditioner is doing, from 35 degree it is again cooling to 30 degree. Okay, so here it is doing some, here it is receiving some heat, and here it is receiving some work because your air conditioner is working. Okay, so it is working, that is why you are able to maintain the temperature from 35 degree to 30 degree. Okay, so in one process you are heating the system, in another process you are cooling the system, means cooling in terms of work interaction. Okay, so when the system is doing some work, so the temperature is reduced from 35 degree to 30 degree centigrade. Okay, so in a closed cycle, for a closed system, the total summation of total work, okay, summation of work will be equals to summation of heat. The amount of work for the whole cycle, means there may be numbers of processes. Here two processes are there, so there may be numbers of processes. Okay, so where in some processes some work will be done by the system, in some processes some heat will be receiving by the system. So all these interactions of work and all these interactions of heat, these are equal. Okay, means the energy is conserved. Okay, are you getting? So by mechanics, this definition says that the energy is total energy is conserved. Energy, whatever it is creating, that will be equal to energy what it is destructing. Okay, so total energy it is conserved. Understood? So there may be numbers of processes in a complete cycle. Here there are two processes. Okay, as because minimum two processes should be there in a cycle, that is why I have considered a minimum one, so that we can understand this first law of thermodynamics in a better way. Okay, so this work means what? It is also a kind of energy. Means suppose your air compressor, means inside the air conditioner, the air compressor it is using, or inside the refrigerator. Okay, refrigerator air compressor will be using, and inside the AC the evaporator will be working, isn't it? So both way they are working. So when they will be working, so they will be cooling the system, someone will be means giving heat to the system. Okay, so means what? You are getting energy. So total energy, whatever it will be in the form of work, so that will be equal, summation of all the work will be equals to the summation of heat. Okay, for a complete cycle, I am not saying for a single process, for this complete cycle, whatever be the amount of energy, okay, Q1, Q2, Q3 will be equals to W1, W2, W3. Okay, I am not taking the sign positive negative, just it is it will be equal. Q1 plus Q2 plus Q3 will be equals to, if there are 3 processes or 6 processes, then equals to W1 plus W2 plus W3. Okay, so that is a first law, that is the first law of thermodynamics for a complete thermodynamic cycle. Understood? Again I am repeating. So when a closed system executes a complete cycle, the sum of heat interaction is equal to the sum of work interaction. Okay, so I have taken the example of your room, from 30 degree to 35 degree, the sun is heating. Okay, means the system is taking some heat. Okay, I have taken the heat energy, but here by arrow mark Q can be denoted. So here from 1 to 2 the system is taking heat, and from 2 to 1 means from 35 degree to 30 degree. So how we will gain that temperature? Unless and until the system does not cool itself, so we will not get. So if externally we will apply some work, okay, we will apply some evaporator, then only the temperature will be from 35 degree to 30 degree can be achieved. Means we are doing some work. Okay, means we are doing some we are giving some energy to the system. So that amount of work in a cyclic process will be equals to that amount of heat in a cyclic process. Okay, so that is a cyclic process. So this is the first law of thermodynamics. Okay, now alternate statement is also there. So you can say that when a closed system undergoes a cycle, so it should complete the cycle. Okay, from the initial state should be equals to the final state. So when a closed system undergoes a cycle, comma, the cyclic integral of heat is equal to the cyclic integral of work. Okay, cyclic integral of heat is equals to cyclic integral of work. So that same thing actually it is written mathematically. So mathematically it is written by cyclic integral. So one integration sign will be there. So one circle at the middle of this integration. So you need to introduce. Okay. So this is the integration sign. So del Q means change of heat will be equals to cyclic integral of change of heat will be equals to cyclic integral of change of work. Okay, so in this way, so you need to write the statement, okay, of the first law of thermodynamics, or mathematically you will be able to write by this form. Okay, so if you just split this for these two processes, 1 to 2, 2 to 1, so what you will get? So let's suppose from 1 to 2, okay, the total heat, it is not mandatory that only in one process the system will be taking heat. In one process the system may take heat, the system may do some work. Okay, means Q1 W1, and from 2 to 1 it is not necessary that only work will be done. Okay, so some heat interaction may happen, mean here Q1 W1, here Q2 W2 may be there. Okay, or here Q1 will be there, here Q2 W2 will be there. So like that, in a process the heat and the works will be associated. Okay, so let's suppose here interaction of work and heat are Q1 and W1 for process 1 to 2, means for part A, and for part B, let's suppose it is Q B and WB. Okay, so for this whole cycle, so how we will write it mathematically? So QA, so this part, A part 1 to 2, QA 1 to 2, so 1 to 2 it is written, plus QB 2 to 1, QB means in this part 2 to 1 part. So summation of this Q, because by first law it is said that summation of Q will be equal to summation of work, means from 1 to 2 whatever be the work, WA 1 to 2 means work done in this part, in part A, and work done through part B, WB to 2 will be equal. Means either you can write this way, or you can mathematically write this way or this way. All the things are correct. Okay, all the three things are just similar actually. Okay, so if you are asked to write the first law of thermodynamics for this cycle, then you will have to write this one, or specifically this one. Means mathematically this is the correct one. Okay, mathematically this is the correct one, or you can use this one also, but in statement you will be using this theoretical language, but mathematically you will be first writing this one, then below this you will have to write this one. Okay, if no heat interaction and work interactions are mentioned. Okay, so we have assumed that for process 1 to 2 there is a heat interaction and there is a work interaction, and in process 2 to 1 there is a work interaction, there is a heat interaction. That is why we are able to write all the Q and W term for this process to process. Okay, now we will see mathematically one thing, important thing actually. So the corollary actually for this first law. Okay, so what it says that QA means the amount of heat which is interacted in the process 1 to 2 plus amount of heat interaction in the process 2 to 1 will be equals to amount of work done which was involved from 1 to 2 process, and amount of work done from 2 to 1 process will be equal. Okay, so the same thing we have written. Now what is QA? What to do, how you will find out the value? As because this Q, what is Q? Q is a part function. Okay, Q is a part function. So to find out the value directly, you cannot write down the difference QA 1 to 2. You need to integrate it from 1 to 2. Means from 1 to 2 you need to integrate along part A, because it is a part function. I have told you that heat and work are path function. So directly by the difference, you cannot find out the value. Okay. So from here to here, so there the value of Q will be different. From here to here, the value of Q will be different. From here to 1 to 2 through this part A, the value of W will be different. From 2 to 1 means through part B, the value of the work will be different. Okay, so that is why along path A from 1 to 2 you need to integral 1 to 2, you need to integral, so del Q, then only you will get the value of this heat. Okay, Q A 1 to 2 will be find out by this formula. Okay, so instead of this Q A 1 to 2, I am writing here this one. Okay, yeah, 1 to 2 dq, and I will be writing this one negative, because if you just simplify this equation, this minus W A1 to 2, and this term will go to the right hand side. Okay, or you can or you can just move this term on the left hand side to make it equals to 0, means Q A1 to 2 minus W A1 to 2 plus Q B2 to 1 minus W B2 to 1 equals to 0. After that you can write this one, because you know how to find out the value of Q A 1 to 2. So this one, so same thing we will be writing, as because it is a path function, so integration 1 to 2 for this Q A 1 to 2 del Q. Then after rearrangement, when this term will be on the left hand side, that is minus of W A 1 to 2, so minus del W, so it is same along path A 1 to 2, plus this term will be there Q B2 to 1 integration of 2 to 1 del Q. Okay, difference del Q. In integration form we will be writing the difference. Okay, because in the first law I have shown you in the previous slide, minus this one W B 2 to 1, so 2 to 1 minus dW. Now it will be equals to 0. Okay, so means after writing this one, then again you need to write one line, this minus this plus this minus this, then you will get this one because of this one. Okay, so from here what we will be doing now, I will be writing 1 to 2 del Q, same as it is, minus del W, so this term will be remain same. Now I will introduce one negative sign, so 1 to 2, earlier it was 2 to 1, so it will be 1 to 2, so that's why it will be negative, so it will be negative, so 1 to 2 I need to write 1 to 2 along path B, so del Q. Then for this del W, so as because this is negative, so I will write here negative. Okay, because already it is 1 to 2, earlier it was 2 to 1. Understood? So I am writing the same thing, but I am just changing the upper limit and lower limit. Okay, by introducing one negative sign. Okay, so this means 0. Okay, so this is what, so del Q minus del W along path A 1 to 2 equals to, now I will move this term to the right hand side, means same path, integration of 1 to 2 del Q minus del W. Earlier it was del Q minus del W along path A and del Q minus del W along path B. Okay, means difference of the heat and work for this path A, and difference of heat and work for this path B are equal. Earlier I said one thing, that the heat interaction, whatever it will be, let's say it is Q1, and if it is heat interaction Q2, that Q1 is not equals to Q2. But now you can see one thing, the difference of this del Q and del W, means heat and work, is same, and difference of this del Q and del W for this process, one means A and B, so both are same. Okay, means they are behaving like pressure, volume, temperature, T2 minus T1, P2 minus V1, like that it is now behaving, means difference is same for these two processes, but the parameters, means heat and works, are not same for these two parts. Okay, because they are path functions, but here these difference are not path function. Okay, so this difference is a point function. You can see the difference from point 1 to 2, it is equals to the difference of point 1 to 2 through path B, means the difference is equal. Okay, but the parameters during this path, they are not equal. Okay, means whatever Q1 is there, it is not equals to Q2. Whatever W1 is there, it is not equals to W2. Okay, because they are path functions. Though points are same, 1 and 2 are same for those two processes. Okay. So, but the difference is same from here to here. Whatever you are you are just getting the difference in between the heat and work. For this process, B process also, the difference of the heat and work, it is same. Okay, that means you are just getting one corollary. Okay, from this first law. See, since A and B are arbitrarily chosen, so the conclusion is, as far as a process concerned, the difference del Q minus del W remains a constant. Means whatever line you will draw, 1 to 2, okay, means A, B, C, another line also you can draw. One means another line D also you can draw, another line E also you can draw. Okay, from 1 to 2. The difference is same, the difference is constant, but the properties may not be constant, this work and heat. Okay, but the difference is constant. That means what? That means the difference depends only on the endpoints of the process, not on the path. Okay, so note that Q and W themselves depend on the path, but heat and works depend on the path, but the difference does not depend on the path. Whatever be the path, it may be path A, it may be path B, it may be path C, it may be path D, any arbitrary this one, but the difference is constant. Okay, so this implies that the difference between the heat and work interactions during a process is a property of the system. Means there is a property where the difference is not changing, it is a constant. Okay, in between the heat and the work. So this property is called the energy of the system, and it is called the internal energy actually. Okay, so this energy which is stored due to this interaction of heat and work, it is called as the internal energy. Okay, so during the types of energy, we have written that internal energy or enthalpy. Okay, one property is enthalpy is also there. So here the internal energy comes actually. Okay, so this difference of Q and W, it is a property of the system, and it is called as the internal energy of the system. So internal energy is a property of the system. Okay, so it depends on the points. It is a point function. Internal energy is a point function. I have told you, by subtracting the initial point and the final point, so you can get the value, but by subtracting the initial and final point, you will not get the value of the work and heat. Understood? So very important concept. Okay, very important concept. So just I want to show you the slides. Just see the slides. Okay, and just recall in your mind that whatever I have told you just now. What is the first law of thermodynamics? Just go through these slides. Okay, just read the slides. Any doubt for this slide? Please, anyone respond? Parmiki? Yes, please.
No, sir. No, sir.
Understood?
Yes, sir.
Okay. Emil? Understood? So this is all about your first law of thermodynamics. Okay, for a thermodynamic cycle. For a thermodynamic cycle. Now you can ask me, sir, there are two processes, 1 to 2 process A, 2 to 1 process B. So if I want to apply first law of thermodynamics for each of the process, is it possible? Now I will say that yes, it is possible, because what you have learned in the corollary, that the difference of this heat and work, it is one property, isn't it? So which is stored inside the body, it is neither heat nor work. Okay, so that property is called as internal energy. So for this process, so you can find out the change of heat and work. Okay, so that will be equals to the internal energy, means Q minus W will be equals to internal energy, and for this process also the Q minus W will be internal energy. Means here first we are writing the statement of the thermodynamic first law of thermodynamics by using this thermodynamic cycle, because every process, okay, because every system is undergoing some process. So in a complete cyclic process, so you can define the first law of thermodynamics very easily. Okay, and for each of the process, here there are two processes. So for each of the process, if you want to write or if you want to define the thermodynamic first law of thermodynamics, then you need to use the term internal energy, because the difference, whatever be the part A, B, C, D, okay, which connects point 1 and 2, so the difference is constant. Okay, and that difference is called as the internal energy of the system. Means del Q minus del W will be equals to delta E, means difference of internal energy of the system. Okay, so for now I am writing the first law, okay, for one process. So this is one process from 1 to 2. Okay, means from 25-degree, let's say this is temperature, property 2 is temperature, here it is volume. Okay, so from 30-degree, so you are reaching 25-degree. Okay, means temperature is reducing, let's say, okay, through the help of AC. So you are just getting that state. Okay, so from 25-degree to 30-degree, so the system will be going through some static equilibrium point. So when you will connect, so you will get this distinct line or this process. Okay, so for this process, so if you want to write the first law of thermodynamics, then you need to write this one, del Q minus del W equals to D. So why you are able to write this D? Because this is the difference. Okay, difference of elemental difference of the heat and the elemental difference of the work. Okay, so to achieve 25-degree from 30-degree, so you will have to, the system will have to do some work. So in doing the work, so it may release heat or it may just absorb heat. Okay, so heat and work interaction will be there in each most of the processes. That is why, so difference of this del Q minus del W will be stored as an energy, that is the internal energy. Okay, internal energy of the system. This internal energy may be of this this energy, total energy, actually difference of this energy, this is energy actually, this energy may be of internal energy, which is denoted by capital U, or kinetic energy or potential energy of the system. Okay, so this energy, total energy, is composed of the internal energy U, kinetic energy, and the potential energy of the system. Okay, the effect of kinetic energy and potential energy of the molecules are less. That is why this energy, it is directly linked to this actually internal energy, which we will get later when we will be solving the problems. Okay, so basically the difference of this heat and the work, it is the energy of a system. Okay, so which is a point function, this energy is a point function. So E consists of these three parameters: U, which is internal energy; K, capital U, okay, not small u, capital U, internal energy; this Ke, kinetic energy; and potential energy. Now for which one we have written this formula? So for a process, okay, not for a cyclic process. This is only one process, this is not a cyclic process. Okay, it is not completed. So for cyclic process, so how we have to write the first law of thermodynamics, so I have shown you. So for only a process, because any thermodynamic system will be composed of numbers of processes. So for this process, so we'll be using this one. If another process is attached with this one from 2 to 3, then for that also we will be writing the first law of thermodynamics by this formula. Okay, del Q minus del W equals to D. So here it may be Q1, W1, and E1. So if another process is there, it will be Q2, W2, and E2. Okay. So for the whole process, so I will be writing Q minus W. Okay, Q minus W, E2 minus E1, because these are the differences. So Q minus W will be equals to E2 minus E1, E2 minus E1. So difference of this, because this is a point function, the energy is a point function, that is why I can write E2 minus E1, final minus initial directly. But W, you cannot write W2 minus W1. It depends on the path. There may be numbers of path to get point 2 from point 1. Okay, so W2 minus W1, it is not possible. Q2 minus it is not possible, but E2 minus E1 it is possible, because it is point function. Okay, so Q minus W, so E1 minus E2. So similarly for process B, if there is another process B, okay, so I will be writing Q minus W equals to E1 minus E2. Okay, E1 minus E2. So this thing actually you need to remember. So this same thing it is written actually. So I will be sharing the slides. Okay, when this module will be completed, so I will be sharing the slides with you. So the students, so if you have any confusion, doubt, okay, so you can ask me now. We are having only 5 minutes. So is it clear to you, or should I repeat this same class again tomorrow?
No, sir, it's clear.
It is clear, no? I think it is clear. Better I will take some example, okay, and discuss this same thing actually. Otherwise, see, in Viva, these things are actually mostly asked. What is the first law of thermodynamics? So how you will apply this first law of thermodynamics in a process, or and separately for a cycle. Okay, so you will be given in exam, you may be given one cycle. There may be Q1, Q2, Q3, Q4, Q5, Q6. So like that, there may be numbers of Q, there may be numbers of W. Okay, and you may need to write sign conventions also when you are writing this one equation. Okay, for the first law of thermodynamics. So Q1 plus Q2 plus Q3 plus Q4. So if heat it is given to the system, so it is negative. Okay, so minus of Q1 minus of Q2 minus of Q3 will be equals to, if work is done by the system, will be equals to W1 plus W2 plus W3. So like that, you need to write the first law of thermodynamics. So I will give you some problems, then it will be clear to you. Okay, thank you, students. I hope you have understood this topic. Okay, I will share this video in the Google Classroom. So thank you. Now you can leave this meeting.
Thank you, sir.
Yes, sir.
Thank you, sir.